Today we are introducing the concept of ratios. So ratios are all about comparisons. We're just comparing quantities. So here we have graphing calculators, protractors, and compasses. So if we make a ratio statement, we would say this is a ratio relationship. There are, we can see up here, 5 graphing calculators, and there are 7 protractors. So this is what we would call a ratio relationship. There are 5 graphing calculators to 7 protractors. Go ahead and pause and fill in the rest of those. Hey, and what we notice about the next one, it's still 7 and 5 protractors and graphing calculators, but the order was switched. So the order that we write our ratios is going to matter. Then when we get down here, we have protractors to total objects. So it's 16 when I combine all of them, protractors included. Here, it's the number of graphing calculators is, and there are 5 graphing calculators, 16 objects total, so 5/16 of the total. We did play Trashketball in class to collect some data. If you missed that activity, you can just make up some numbers for shots made and shots missed. I said 2 and 5. Then what you would do here is write a statement that describes the relationship. So it'll be just like what's up here. So you might say, if you use these numbers, there were 2 shots made to 5 shots missed. Down here, we're looking at the shots made to the total. You might say there were 2 shots made to 7 shots total. Then when we relate that to fractions, there's a lot of overlap with fraction number sense and ratio language. So what fraction of shots did you make? I made 2/7 of my shots. I made 2 shots, there were 7 total, 2/7. Fractions are also comparisons. What fraction of shots did you miss? I missed 5/7 of my shots. Go ahead and turn the page. Okay, the next thing we're looking at is tape diagrams. So how do we read them? So there's a few things that I'll be looking for when we create tape diagrams. Every time we make a tape diagram, it should be labeled. So you'll notice this is blue and this is green. We're looking at different amounts of paint that create new colors. If you go to the store and you order some paint and you want kind of a blue-green shade, we don't just throw some blue in there and throw some green in there. We need a ratio. Because if I run out of paint after painting a little bit of my wall and I have to go get more, we need to know the exact ratio or the color is going to look different. So this shows us how many parts blue, how many parts green. It's labeled. Has the same starting point because if we're making a comparison, we have to start at the same point, and equal size pieces. Each box is the same size so that we can properly compare them, just like fractions. We do use rulers for this. So we're going to draw tape diagrams, but first we have to know how to read them. So this one, 4 parts blue for every 3 parts green. Go ahead and pause your video and you're going to create ratio relationships or ratio statements using this language on the next 2. Okay, this one would be there are 4 parts red for every 2 parts blue. And there's 1 part white for every 5 parts purple. All right. Now we are going to actually draw the tape diagrams. So if you will turn the page, and you will need a ruler for this part. Hey, so we have 4 ratio relationships here. For every 3 boys standing in line, there are 4 girls. So I'm comparing 3 boys to 4 girls. So the first thing I'm looking for, labels. So I'm going to label this boys, girls. We need 3 boxes for boys. So every time we create a tape diagram, we're always using a ruler, and we're going to use the centimeter side. Notice inches are just, our paper's 8.5 by 11. We don't need a ratio or a tape diagram that big, and then we're going to run out of space. So we're going to flip it over, and we're always going to use the centimeter side. You'll never have to guess what size your boxes should be. You're going to use this same process every time. So for boys, so since I need 3 boxes for boys, I'm going to put this here. I'm going to start at 0, and I'm going to draw a line segment from 0 to 3. I'll bring that down, 0 to 3. Then I am just going to draw a line at every line segment. or every centimeter, so that I have 3 equal sized pieces. Then I'll do the same thing for girls. I need 4 boxes for girls. I'm going to move down, 0 to 4, bring that down just a little bit, 0 to 4. Draw a line segment at every centimeter. Okay, go ahead and pause your video and do the next 3. The next one, for each vote Brian received, Sasha received 6. So that's 1 for Brian, 6 for Sasha. Here, a class counts the number of vehicles that pass by its school from 1 to 2 p.m. That whole sentence is unnecessary. We're not comparing 1 to 2 p.m. We're looking at this. There are 3 times as many cars as trucks. So 3 cars, 1 truck. And a hand sanitizer contains 5 parts aloe, 2 parts distilled water. Pause your video, give it a try. All right. Here is what our tape diagrams should look like.